Good morning, everyone. Welcome back. So let's continue with pointers. We cover the first half of the information that you need to know about pointers, the easy part, quotation marks, and I want to move to the second part, the most interesting part. In particular, I am talking about two instructions that we need to review today, malloc and free. Malloc is the grandfather of what you know in Java as new. So just think about anything that you do with new in Java. Now, the same instruction, the same action is going to be malloc. It's going to be involved with the arrays, and it's going to be involved with classes and objects later in C++. And in Java, when you use new for something, when you do not need anymore that something, well, in Java, you have this garbage collector that hope you remember. So in Java, it was kind of, if I need something, I do the new, I have whatever I need. And when I do not need that anymore, it's like someone else is going to take care of the garbage. Someone else is going to clean the memory. I do not need to worry about cleaning. The only thing that I need to do is create new things and use those new things. And someone else is going to clean. The bad news for C and C++ is you do not have a virtual machine anymore. And because you do not have a virtual machine anymore, your programs are running directly in the hardware, in the computer. So if you create something, now you are responsible for cleaning, for removing that something. So you build something and you need to remove that something from the memory. So you keep the memory clean for the next program to arrive. The complement of the instruction malloc is going to be the instruction free. As a rule, from now on, every time that you do a new, every time that you do a malloc instruction, in some point, you need to have a free instruction that basically is cleaning whatever the malloc instruction that you previously run. So you can think about these two guys as the same way that you think about parentheses. Every time that you use one, in some point, you need to have another one that is kind of the one that closes the scenario. So if I use malloc to create an array X, in some point, I need a free for the array X. But we're going to review examples. This is basically the big picture for the lecture today. Malloc and free instructions that are the equivalent to the new in Java. Now, before we move forward with this, something that I am giving you in these slides, and I want to review some of them, not all of them. Some questions. We are moving to a point in which the midterm exam is close. My idea is to have the midterm after we finish with C and probably with a little bit of C++. I am going to talk about that next week, but in some point we're going to do an exam. And for that exam, well, questions, which kind of questions you can have in the exam about pointers. In particular, I am worried about pointers. It's an important topic. It's a hard topic. So for your exam, question one, some of these are going to be pointers, but other questions in general. What if you have an exam or a quiz? Quiz 3 is coming next week, by the way. What if you have a quiz or an exam with this source code in Java? And the question is, what is the equivalent for that in C? And well, I give you these 4 options. Can you guess? Do you have enough information with the things that we have reviewed so far in order to answer this question? What do you need to check? A, B, C, or D? Okay, I have some votes for A. Good. Okay, important things that hopefully you remember. Type int is the same, so int x equal 5, probably is going to look the same both in Java and C, C++. When we talk about this float number, the first thing to remember is, well, this F here, you do not need the F when you move to the C. That is something that you need in Java to specify between doubles and floats. So hopefully you do not miss the F. You do not need the F in your programs. Hopefully you have been working, copy paste my examples. You have been using floats, hopefully, and doubles, hopefully, and you notice that the F now is not mandatory. But the most important part here is with this println, you should be familiar that now is printf, the instruction that we have been using. And well, you cannot do the plot between strings anymore. You cannot just do these things. But now the things that you need to do is this printf, and it seems that I want to print x and y. So x and y, x and y, x and y, oh, tricky, ampersand x and y. Hopefully you remember that the ampersand is something that you need with the scanf, right? The scanf needs addresses, but definitively you do not need the ampersand here for the print. You only need x and y. With that idea, we can be sure that the C is not the answer, right? If you do not need the F, maybe we can say that B is not the answer either. I am using here an asterisk, and it's you like, oh, okay, this program do not seem to need pointers yet. So just by that, I agree with your A. Easy, right? I mean, you answer in less than 1 minute. If you have an exam and your exam is 1 hour and you have like 20 questions like this, well, some more complicated, some more easy, but I think we're fine. Another one, easier. Which of the followings are not primitive data types in C? So anything that is not a primitive data type, obviously you can check more than one. These do not exist, it's Java. What about the short? This is the tricky part. Short is a primitive data type in Java, yes or no? Short. I need you to remember, short is a data type in Java. In Java, yes. In C, is not a data type. In C, is a modifier. Remember? The data type is int. The modifier is short. If you use short alone, by default, the data type that is being used is int. But short is not a data type. And I know it's tricky. It's tricky because you can do short x equal 5. And you can show me that in your compilers and it's going to work. It's going to work because the computer is using there as a default data type int, not because short is a data type. So short is not a data type. Bool, another tricky, because bool is a data type, yeah, but it's a data type in C++. The question is about C. We reviewed this. Bool is not. Long is not, just like the short. Double float, yes. So my answer, the correct answer should be something like this. Good. Usually in these questions, you have partial credits. So it's like 25% each of the checks, but it should be easy to get full marks. Again, your exam, you do not need the book, review the slides, everything that we review, the videos, and copy paste the source code that we're using. And hopefully this is another easy question. Moving forward, which of the following are mains? Correct declaration of main in C. This is, yeah, the midterm in 2 weeks, more or less. I am planning to do the midterm in the week 8 or 9, depending on how fast we move. But it's like October, the first or second week of October. That is the reason, because I am starting with some reviews. So you have 2 weeks to recapitulate things. So this one, hopefully you agree, looks good. 1, 4, 6. Okay, important things, your mains, if you do not put any parameter, that is good. If the data types can be int or void. This one is tricky. If you put nothing, by default is int. We have reviewed some examples, so I am happy that you mentioned the number 4 as correct. Doesn't matter that there is no data type there, it's correct. Obviously, you are going to agree with me. This looks like Java, so we haven't talked about the static for the methods. That is, again, Java, not C. So the second, hopefully, is not one of them. I need to show you example with the main in C using parameters, but these are going to be the parameters. So these two are also options that could work, but we need to review them later. But at least the 1, 4, and 6, as you mentioned, those are the ones that, with the things that we have reviewed so far, they are correct. Good. So, oops. These ones are the ones that I want you to review, not during the lecture, later, but this is the kind of questions that you're going to have in your exam regarding pointers now. And small program, the question, and open question, use a box there. And the question is, what is the output? What this program is going to do? And my recommendation, what I think you should do, you can use paper during your exam, so you can take notes, empty paper, no notes, but a paper is okay. So if you have a piece of paper, my recommendation with this kind of questions is draw what you have in the memory. I am talking about the variable is I, it have the value 3. Oops, this looks like a pointer. So I am going to have j, that is a pointer. I don't know yet where it's going to be pointing. And I have another variable here. Maybe you can mark this one to remember that it's a pointer. So it should be an address, what you put inside. And then, well, here I have my ampersand. J equal ampersand I. And in this point, and remembering what we reviewed the previous week, is like ampersand, the address of a particular variable. And I am going to store the address in the pointer. Hopefully you agree, and it is clear that the first 2 lines in this program are creating something like that. And finally, the print. And what is happening with the print? Percentage D. I do not know yet what is going to be the answer, but if you follow the percentage D, the answer should be a number. Okay. It's going to be a number, but the question is which number? And I love the tricky things. What is happening there? Can I have this asterisk asterisk there? What is the meaning of that? Any of them is multiplication? Or all of them are pointers? Or what is happening? Hopefully you agree with me. You cannot use two asterisks because we do not have pointers to pointers here. However, you have one variable. Looks like the first asterisk could be multiplication. The second asterisk is together with a pointer, yay. And then I have another asterisk that should be multiplication because I do not have pointers there. And then I have the minus, and then I have an asterisk with the yay again. This is what I have in the print. Again, I am testing your understanding of the asterisk for the pointer. To remember that you have only a pointer to a value. You use only one asterisk to the declaration. Therefore, you cannot use two asterisks for anything below. And well, the others, the asterisk is still multiplication. So having this or doing the mapping to this, hopefully you agree that, well, this is the variable multiplication. What is this? Asterisk j according with my map here. Hopefully we can agree asterisk j is exactly the same that the variable, right? So I have 3 times 3 times 3 minus 3. And the last part of the question is what is going to happen first, the multiplications or the minus? Maybe this multiplication and then this minus and this multiplication, or just left to right or right to left. Precedence of operators. The same precedence in C is the same precedence that you know from Java. So precedence of operators and pointers, and then you can tell me the answer for the question. I agree. Multiplication go first, subtraction is the last one. All the multiplication should happen first. So in this case, left to right, just like that should happen. So 3 times 3 times 3 minus 1 is 24, maybe 26, 27, 25. Okay, so open, or maybe I can give you options like ID. Zero. Those are questions that you're going to have in your exam. So my recommendation, 2 weeks, more or less, start practicing. You can review this later by yourselves, an array, another print, and playing with the array, classical notation or with pointers. And one of these is the output of the print. In this case, I am not asking you to write the output. I am giving you some help. And now we can move to malloc. So please review. I am going to try to share with you this kind of questions so you can start testing yourselves in preparation for the exam. Again, more or less 2 weeks, October 1st or 2nd week, depending on how fast we can move with some topics that we need to review. but it's going to include obviously C, Java, and hopefully C++ at least 50%. I don't know. I mean, usually I am going to show this kind of questions during the lectures. These are the kind of questions that in some point I ask you when we are recording here. I think the textbook includes some questions, not exactly like this, maybe more about doing the program. You can try that. At the end, if you are familiar with the meaning of the symbols and you understand the symbols and what is happening, this kind of question should be easy to answer. But again, practice. Play with the source code. That is my best recommendation. If you are going to review something, be sure to copy paste all the source code from all the slides, compile the source code, play with the source code, change something, run. Do not be afraid to make mistakes or to ask your IDE to do something crazy. Go ahead, see what happened. Good. And any question? Well, let us know. Anyway, moving forward, malloc and free. Now, as I mentioned before, they are going to be they are the grandparents of the new in Java, right? So the only reason because I mentioned this is you know exactly what new do, but now I need to share what malloc and free do. Some background. I need you to remember something. When you run a program, what happened is your program go to the memory. We talked about this at the beginning when we reviewed the introduction of what happened with the program running. When you run a program, that program have access to a space in the memory. In that space of the memory, you have one place in which the program is going to put the source code of the program. A program is never executed from the disk. When you click in your program, in your hard drive, in the icon of your program, the first thing that is going to happen is the program, not the source code, but the machine code, go to the memory. The computer read your program from the memory, the RAM memory, never from the disk. So your program have a space in the memory, and one of the things that is there is the code. Again, in the machine language. Now, another thing that is going to be there in one particular part is the global variables. All your global variables are going to be in a particular place inside of this space that corresponds to the program. Now, next. Every single method, starting with the main, is going to have its own space inside of this big place. The space for the method, obviously you start with the main, but when the main call another method, that other method is going to have its own space. The local variables go here. If you create a local variable in main, it's going to be in some place in this playground. If this method creates a local variable, it's going to be in some place in that playground. If you put parameters in the method, well, the parameters for this method are going to be here, like local variables, parameters are local variables, and so on. Question in your exam, what is the name in which you are storing all these methods, local variables, the global, and so on? These blue boxes have a name. The name is, yes, thank you, the stack. Remember, Stack Overflow. Stack Overflow, if you create a lot of methods, in some point you are going to fill that place. The easy way to create a lot of copies of a method is a recursive method that never stops. You can create a recursive method and you crash your stack. Obviously, your computer is not going to crash because encapsulate your working area in a particular place. But that's a different story. The point is stack. What is the name of everything else? What is the name of anything that I have outside of my blue boxes? The heap. Muy bien. There you go. I have the heap and I have the stack in blue. Now, something that we review in Java. In Java, you create a local variable. It's here. you create a global variable, is here. Always, always, always in Java. If you create an array, it doesn't matter that the array is global or the array is local. You use the new, right? Think about it. Create an array in Java. You need the new. It's mandatory to use the new. It doesn't matter that your array is local or global. Always you use the new. The consequence of that is your array in Java is something like, this is the pointer, remember? And the array is always here. But it's global. The global is the pointer, but the array is here. But it's local in another method. The local is the pointer, but the array is there. Always, always, always in Java, your arrays are in the heap, not in your stack. Why? Because it's what Java do to handle big variables. In this case, the arrays are big, have a lot of elements. So by default, Java put arrays outside of the stack, because in that way, you are going to have more space in your stack. Well, at least you are not going to run out of space quickly. Arrays are out. And the only thing that is local or global is the reference, the pointer, that gives you the address of the first element of the array. What happened with objects? With objects, you do the same. You cannot create an object without the new keyword, right? Well, same idea. If you create an object in the main, the object is not in the main. The object is never in the stack. What you have is a pointer to the object. I use circles to represent the object. The object is in the heap. Well, I have an object and the object is local to a method. The object is in the heap. What you have local is the reference to the object. This is the picture of a program in Java. Every single time that you use arrays or objects, they are in the heap. They are never in your stack. Good. Any object that you create, outside. Now, my point is, this keyword in Java, every time that you use new, what you are doing, the goal of the new instruction is telling the computer that you want to put something in the stack. The new instruction in Java gives you access to the stack. And that is the reason, because in Java, you always, always, always use the new for objects and arrays, because objects and arrays should be in the heap, sorry. You use new to create something in the heap. Always, 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 an object or an array is in the heap in Java. Good? Now, hopefully you notice that now that we have been working with C, I did the following in several examples. I create a main, and inside of the main, I create an array like this, and I do not use new. First, because new is not a keyword in C, but in general, what I did is use like an array of 5, and immediately I want to put an element in the first position. There is no new involved. In C, if I use this instruction, this green array in a program in C is in the main. Okay, it's going to be in the main. It's a variable X. I am going to have here my variable X. Oh, it's an array of 5. In C, you can create arrays like this, and those arrays are going to be in the stack, not in the heap. In Java, never, never, never an array can be in the stack. Always, always, always are in the heap. In C, you have the control. You decide if you want your array in the heap or in the stack. All the examples that I have shown you so far, because we haven't used any new or equivalent, all the arrays that I have created, all the pointers that I have created, they are in the stack of the program. All of them are inside of these blue boxes that I am showing you. This is the first big difference between Java and C. Makes sense? If you do something like this, arrays that are going to be in the stack. But you told me that the arrays cannot be in the stack because the stack is going to be full so quickly. Yes. So the recommendation is do not do this in C. Java, virtual machine, the nanny. Java take the decisions for you. Java do not allow to put arrays or objects in the stack. Java take the decision. They are going to be always outside. Now with C, your choice. You want to put the arrays in the stack? You are aware that the stack is small and it's going to be full quickly. Well, maybe you are doing only examples like the one that I showed you, arrays of 5 elements, 10 elements. You can do that. Your decision, your responsibility. Now, you know what? I prefer to have my arrays outside. I want to have an array, but I get the idea that if I put the array, the elements in the stack, my stack is going to be full. So I want to have my arrays out. What I need to do? The same thing that you do in Java. Use the instruction new. Wait, in C, the name of the instruction, malloc. Every single time that you read a program in C and you read malloc, what is happening is that program is using the heap. That program is going to put something outside of the stack. What is going to be that something? An array, for example. Quick question, what is the meaning of malloc? Like, malloc. Thank you. Yes, agree. Memory allocation. Memory allocation, yeah. You are using your memory and you are doing the allocation of something. It could be heap allocation or memory heap allocation, whatever. The name was malloc. Makes sense, guys? In C, if you use malloc, your array can be outside. If you do not use malloc, like in this example, your array is going to be inside. Now, I am not working with objects yet, but when we move to C++, exactly the same thing is going to happen. You can create objects without the new, and your objects are going to be in the stack, or we're going to review that we have the new back. Malloc is going to change the name and it's going to be new. And we can use new, and we are going to be able to create objects in the heap. Use new or malloc, working with the heap. Do not use them, working in the stack. That's it. The only thing that I need to show you is how to use those instructions, because now you know what is the goal of the instructions. How to use the instructions? I can be back here and we can check some examples. Let's see. Number one, the first library, you know the library, the one that you need for the print and the scan. A new library in red. What do you think is the meaning? stdlib. Okay, a good question. Standard library, yes. stdlib, standard library. stdio, standard input output. You will notice that the people that create C like this use of short words. and that is going to change totally in Java. Yes, the question, what is better, to use the stack or the heap, is something related with the performance. You are working in the memory. The performance is going to be the same. Accessing the heap or accessing the stack, you are accessing an address in the RAM memory. The performance is not going to change. The only thing that is going to change is the stack is small. The stack, if you put a lot of things inside, Stack Overflow, you are going to crash the program. The only reason because you use the heap is because you do not want the stack to be full. Think about this. If I put this main and this main create a lot of information, a lot of arrays, a data structure that is complex, you can have this main using the full stack. And the problem is that when that main wants to run another method, the other method cannot be able to run because there is no space to put the method. Something that you do not want to happen in your programs is to saturate the stack. You always take care of the stack, like the space in which you are working, the space that you need to run a method. Something as simple as calling a method needs memory. And if you do not have the memory, the program is going to crash. So usually when you are going to create a data structure, I don't know if you already take the class or you're going to take the class later, but when you create a data structure, a tree, a linked list, a stack, there are stack data structures, or a queue or whatever, usually for your data structures, you're going to be working with news and mallocs. You're going to put your data structure, all your information in the heap, because in that way, you are using the full RAM memory of your computer instead of use this small space. So it's not about speed. It's not about something being faster than the other. The speed is the same. It's all about avoid the stack to crash. That's it. That is the only big thing. Good. So going back here. Standard input output for the printf and the scanf. And now stdlib and stdlib is the library that is going to give you access to malloc and free. They are functions, and those functions are in the library, standard library. Good. For the new in Java, the new in Java was a keyword. For that one, you do not need any library. You do not need any import for the new. In C, they are functions, and therefore they are in a particular library, in this case, stdlib. Now, thinking about what we need to do. Well, number one, my program. In this example, I am creating a variable just to keep using variables, x with the value 5. And I need you to be familiar to remember always, if you have a variable, that variable have a name, but always also have an address. So I am going to put an address there, a random address. It doesn't matter which is the number, it's just to remember that there is an address, and I am going to use hexadecimal value used to identify the value that is inside and the number that represents the address. I put a variable there, used as a reference. The important thing, a pointer. A variable to store an address. Always, malloc is going to return an address. Malloc is a function, and that function returns an address. In particular, and I put this here, the casting, used for you to remember. Malloc is going to return an address, but it can return the address of a char. It can return the address of an integer. It can return the address of a float. It can return the address of a double. Return the address, but remember, the address, the pointer, always need a data type. The address is the beginning, and the data type is going to tell you the end. Is the address of an integer? Good. So this is the address of the first byte, but because it's an integer, the full information is from this point, 4 bytes more. It's a character. Okay, this is the address, but because it's a character, I am only using 1 byte. You need the data type. The computer needs the data type in order to know the size. So malloc is going to return the address. I can explicitly indicate the address of what. In this case, this is a pointer to integer, so I can tell, well, this guy is going to be equal, is going to store the address of an integer that is going to be returned by malloc. And malloc is a function, therefore I have parameters. Tell me, do we understand what is the parameter for the malloc? An integer number. What represents that integer number? Like in this case, size of int. Yes. Malloc is going to have one parameter. That one parameter is how many bytes you want. I am going to give you space in the heap. Tell me how many bytes you have. Notice what is the logic here. The malloc don't care if you're going to store an array, an integer, a char. Malloc do not work with those details. Malloc need to know how many bytes you want. And it's going to give you that number of bytes, period. Now, in this case, it's going to give you 4 bytes, size of int. You can put the 4 there, but remember, because the size of the int or any other type usually could change depending on the computer in which you run your program, it's a good practice to, instead of using the 4 or the 2, ask for the size. At the end, size of int is going to be 4 if you are running in a new computer, or it's going to be some other number. So you can put the 4 if you want, like working in your laptops, or you can put size of whatever you want. It's going to be a number also, remember, and it's going to give you 4 bytes. And then with this casting, you know that it's going to give you the address of the first of those 4, and it's going to work with those 4 like only one integer number. What you are going to have is this variable y, pointing to some place, and that some place is going to be these 2 are in the stack. This one is outside in the heap. That variable, this blue box, is in the heap. Notice something important. This is the first time that I show you an example in which a particular variable have an address, but do not have a name. I have a name for X. I have a name for Y. My variables, X and Y. This box here, the one that I create in the heap, that one do not have a name. It's not a variable that I create with data type and a name. This one is the 4 bytes that the malloc is giving to me, and this one is the address of the first of the bytes. And the address is stored in a pointer, and that is the pointer that is going to give me access to this space. What do you need to do to have access to that space? Name of the pointer, and if you remember the asterisk represents this arrow. Asterisk y equals 7, and I have a 7 there. I ask for a space in the heap. Malloc give me that space, and I can use the address of that space with the asterisk thing and put information that belongs to my program, but is stored outside. Now, I do not have only my stack. I can put information in any place in the memory. The only thing that I need is to ask for the space. Malloc is going to work with the operating system to check some free space. It's going to work with the operating system to reserve that space to me. And once they negotiate the thing, I am going to have the address, like the key. And with that key, the address, I can go and put whatever information I need there. The only thing I put this is kind of to be explicit. This guy is going to return an address. And I just want you to remember the address of a char, the address of an integer, the address of a double, they are different. It's a good practice to do this, to specify explicitly, hey, that malloc is going to return an address and that address corresponds to an integer just because I am going to store that address in a pointer to an integer. It's a good practice, but if you remove this thing, it's going to work. Well, unless you're using a fancy IDE and your FIC IDE is going to show you a warning, you are not doing the casting of the malloc, but that can work. Good. Again, good practices. This and this, just to make sure that both things match. Now, if you do some prints, I am pretty sure that you remember this example that we did before. You can print asterisk y, you can print y, you can print the address of y, and you can do the address of x, you can do x. Can we do asterisk x in this example? I am missing asterisk x. Can I do a printf of asterisk x, or that is an error? Asterisk x. Can I use the asterisk before the variable x? And hopefully the answer is no. Why I cannot do that? Because x is not a pointer. The only way to use the asterisk before a name is if that is the name of a pointer, right? So the asterisk only for pointers, because remember the asterisk is the line that is connecting things. This is a variable. The variable do not point to anything. The ampersand, you can use the ampersand with anything. The ampersand is going to give you these addresses. Even you can use the ampersand with this one. It's going to give you the address of that variable in the heap, and you are going in the stack, and you are going to notice no difference between the stack and the heap. They are addresses, use addresses in the RAM. And obviously for both, you can use the name, and the name is going to print whatever is inside. This one do not have a name, so you cannot use the name. The only way to access here is using y, in particular using asterisk y, right? So 7 is asterisk y and the asterisk 7, an address, the address of y, an address, the address of the pointer, the address that I am pointing, the address of the box itself. So this one, the letter alone, is what I have inside. This one is the address of the box that have the other address inside. X alone, 5, the address of the variable, this thing, 5, and the other thing. And you are going to notice that the addresses are kind of similar because you are going to be working in the same block of addresses, your stack. So there are not going to be a lot of differences, the last numbers. So you can imagine that they are kind of close in the same space of your RAM. Any question with this so far? The only last thing, notice that free is a function and receive a parameter. Do you notice what is the parameter for the free? The address that you want to clean. What is the address? The one that you store in the pointer. Why are you using y? Can we use asterisk y or ampersand y for the free? No, because I want to clean the address 1C in my example. I do not want to clean 78. Moreover, I do not want to clean, if I use the asterisk, I do not want to clean the 7. I want to clean whatever is in 1C, and this is the space 1C, the free. Question: what happened if for any reason you forgot this line? You copy paste my program, but you forgot the free. What is going to happen? Compilation error, maybe? The compiler is going to tell you that something is wrong. Number one, no compilation error. There is no exception. Your program is going to work perfectly fine. In terms of the execution of the program, this line is not doing anything. You can put the line, the program works. You can remove the line, the program is still working. Bad news. Without that line, you are keeping garbage in your memory. Because without this line, your program can finish. When your program finishes, the computer clean the stack. All these variables here are going to be cleaned automatically. The stack, when a method finish, the computer clean. Anything that you put on the heap, like this small variable, is going to be there forever until you reset the computer. The most common thing that happen when you run programs in your computer is that in some point the computer gets slow. In some point, the computer needs more memory. In some point, you can close all the programs, but the computer is still using a lot of memory. Or a program that you want to run, a game maybe, still tell you that you do not have enough memory to run the program. So you have memory problems, but you already close everything. Well, the reason is because one or more of the programs that you run previously put garbage, mallocs without freeze. And therefore, your memory is really full of garbage. And the only way to clean the garbage, well, the easy one is reset the computer, you reset, all the memory clean, and then you can run your program with your clean memory. Yeah, this 7 is going to be there as a reserved space. So when someone asks for memory to the operating system is not going to touch that 7 because for the operating system, someone is using the 7. However, you can use pointers and somehow create a variable that maybe is here. And you can use this address plus 20, and suddenly this address plus 20 give you access here, and therefore you can change the 8. But still, this is like private property for the operating system, even though another program using this technique of, well, I can be here and plus something, I get there and I make changes, but still is private property. So still, when you try to create some data structure or when you try to negotiate with the operating system memory, for the operating system, this is private, is belongs to someone else. So it's going to be garbage, even though you can kind of put data inside of this garbage space. So yeah, obviously. Well, yes and no, guys. One of the things that the operating system do, the new ones, is they have kind of a garbage collector. So if this 7 is there for some time and there is no reference of use, this operating system take care and remove. Usually the point is be good programmers. Even though the operating system can clean, it's like being good guys, put freeze to your mallocs. That is kind of the idea here. You go to the classroom, yeah, you can eat or drink something. Yeah, you can leave your garbage there. Yeah, at the night, someone is going to go and clean everything. It's not nice to do that, right? The nice thing is you keep your garbage with you and you put the garbage in some particular place. When you do programming, it's the same. You can do your programs without freeze. It's not a nice thing to do as a programmer. So my message, the thing that I need to tell you is put freeze to your mallocs. That's it. Good. It's part of the research thing. Some things are very easy, like a variable like this one is very easy to detect. But think about something more complex, like a data structure tree. Some things are very easy for the operating system to clean. This is one example. Other things can be tricky and complex. Moreover, the worst thing is that in some point, your garbage can play against you. What if you want to put 5 gigabytes of data in the memory because you are doing some kind of crazy operation? You're playing with video, or you want to do a video game with a lot of elements, whatever. Your garbage can be something that avoid your program to run properly. I mean, it's not only about others, but it's also about if your program, your software need a lot of memory, in some point your own garbage is going to make your program to look bad. Anyway, frees, mallocs. You do not put the free, you are keeping garbage in the memory. That is not a good thing to do. However, the garbage, like in this example, you can remove the free, the program is going to work. The free is to clean the garbage. The free is not doing any particular functionality or activity for the program. Is use the complement to the malloc thing. Good? So what about this one? My previous example, I want one simple variable. And I am sure that you're thinking like, well, and what if I want an array? Okay, so you want an array, maybe like an array of 3. The good thing is the arrays are consecutive variables in the memory. Remember, that is the definition of an array. So, okay, I want this y to be an array with 3 elements. That is what I want. And it's going to be integers. If you do something like this, you are going to have your 3 elements in the stack. I do not want my 3 elements in the stack. I want my variable y in the stack. And I want the elements in the heap. What I do? Well, just like before, you can use a pointer. Remember, 1 square bracket, unidimensional array, 1 asterisk. This y is a pointer. We reviewed that before. Now, a pointer is going to be a pointer to an integer. Okay, malloc, 1 parameter. Can you tell me what is the parameter? In the previous one, size of int. In the previous one, 4. Now, 12. 12? Yeah, I am asking for 12 bytes. This is 12 bytes. But I want an array of 3. That is the reason, because here you are telling me that is a pointer to an integer. Therefore, I have 12 bytes, but you are telling me that you want to handle this like integers. Okay, so you are going to use blocks of 4 or whatever is the size of integer. So when you do something like the pointer plus 1, it's going to be the pointer plus 1 time the size of the type. The pointer plus 1 with integers is going to be the pointer plus a value 4. If this one is the address of the first element, remember that we reviewed before? Well, this one is like that address plus 4, and this one is that address plus 8. That is what's happening. In order to create an array, you do the same that when you want to create a variable. One variable, size 4. What variable you put 4 here? An array of 2, an array of 3. But in order to play safe, you can multiply the number of elements that you want times the size of the type. That's it. Looks like you are playing with the hardware, right? Byte level. Java do the same. The only thing is you do not write this. This is what the Java virtual machine do, the low level. Okay, so according with this, you are telling me that I can use this notation. You are telling me that after this line, according with what you mentioned, even though I am creating 12 bytes, I can use the name of the pointer, but given that it's an array, I can use these square brackets and I can put like the element 0 and I can make this equal to 1. And that instruction is going to put this one here, even though that is in the stack, in the heap, and even though I create a pointer and I use the malloc. Yes, you can do this. Well, I don't like that one. I prefer the other version. I prefer to use this asterisk, the pointer plus something. Obviously, you can use the plus 0, and these two are the same. But you can use plus 1, and it's going to be this element. You can use plus 2, and it's going to be this element. Remember, it's plus 1 times 4, or plus 2 times 4. The computer is going to do that multiplication. You do not need to worry about it. And what happens if you do y in the position 100 equal to 1? Can I do that? And the answer is yes. So you are telling me that, number one, we are not in the stack. We are in the heap. So we are outside in the big memory. And what I have is a pointer to a space that I allocate with malloc. But then I can make a mistake and put here a big number. And that big number is basically some crazy position there outside of my slide. And I can have access and put some value. Yes. Well, it's going to be the place 100 times 4. So 400 plus the address, in this case, 1C. So if you do the math, like, okay, the original address was that plus 400, because remember, it's 100, but as an integer, is each one is 4. So it's going to be this address plus 400, and that is the address that you are going to modify to be kind of specific, right? And what if in that address another program is running? Or maybe the operating system is running, or the antivirus, or whatever. You have a program that is causing problems to another program. It's the computer, it's the memory. You have access to the things. That is C, the power of have access to the hardware. You're going to override information. Good, easy. Now, moving forward, obviously, this, or this, all of them work. Any format that you want to use is totally fine. Printing, as before, you can print using this, like Y0, 1, and 2, and you're going to print what you have inside. You can work with asking for the address of Y in 1, and it's going to give you the address of the first byte there. You can play with asterisk Y plus 1 and print that, and it's going to print exactly the same that this notation. So everything that we discussed in the previous lecture with the asterisk and the square brackets and so on still work. The only thing now is with the malloc, we are using space in the heap. That is the only difference. And Did you notice the free? I don't know if you remember in Java, but in Java you do the new, period, never clean. Worst case scenario, if you have an array of objects, well, you need to do the new for the array, but then you need to do the new for each element in the array. So somehow the array and the elements, different things. Here, it doesn't matter that this one is the address of the first element of an array, or that one is the address of a variable like before. The computer don't care. It's like, you want me to free y? Okay, this is y. And this y have the address to an integer. This is the address of something. That something, according with what you did in the malloc, that something, 2 bytes. This free y is going to clean the 12 bytes. This free, one instruction, one line is going to clean those 3. The only thing that you need to do is to remember the pointer. That's it. Obviously, if, for instance, here, you do something like y equal the address of x, what do you think is going to happen if, by mistake, I did the malloc, I do this before the free? Well, you are telling me that you have a variable x here, that variable x have a 5. And in the moment that you do this instruction, what you are going to do is, whatever is the address here, the address of x, you want to store the address of x in y. So this 0x11 is going to be stored there. And at the moment that you do that, this pointer is pointing there. It's not pointing here anymore. If you do this, you are not able to clean the memory anymore. You do not know where is your garbage. Even if you want, this free y is not going to clean these 3 blue boxes, because now this free y is gonna try to clean this single small variable. Makes sense? So you need to be careful. Do not touch the pointer that you use with the malloc until after you do the free. If you do something like this by mistake, your garbage is there forever. Good? Any questions so far, guys? Malloc and freeze. That is correct. Well, primitive data types, they have a size in the memory. We review the size of the primitive data types. For instance, the integer, size 4 in most of your computers. Before, size 2, older computers, 32 bits computer. But now in the 64 bits, basically the integer is 4 bytes in everything. Yeah, it is okay. That is a very good question. After the free, like here, you can use this and it's perfectly fine. I mean, you can reuse your pointer in all your program. That is good. The only thing is, be careful with this. If you change the value of y before the free, you cannot access to the address that represent that one. But after, it's fine. Moreover, you can create this pointer and you can do a malloc, work, a free, and then you can use the same pointer for another malloc and free, and another malloc and free. It's a variable like any other. So you can reuse the same variable. You do not need to create new pointers. The only thing is be sure that you do the free before changing the value that you store there before missing access to a particular address. But yes, it's okay to use the pointer after the free. Good? Okay, as usual, my recommendation, copy paste this, play, copy paste this, play, and think about what is going to happen with 2D arrays. Because 2D arrays are like this. 2D arrays are a pointer pointing to an array, and this one is an array, one-dimensional array, in which each of the elements is a pointer to a one-dimensional array. Bad news for you guys. Multidimensional arrays do not exist. The only thing that you have in the memory are consecutive elements in a line. The only thing that really exists are unidimensional arrays. When you want a two-dimensional array, that is the tricky part. Is one pointer to a one-dimensional array, and each of the elements pointing to another one-dimensional array. What happens if I want a three-dimensional array? Each of these elements pointing to a one-dimensional array. Exactly. Arrays of arrays of arrays. What do you do if you want to create a bidimensional array in the heap? Hopefully you agree with me that we need a malloc here, and we need another malloc here. A malloc for the array that is going to have all the addresses, and then a malloc for each of the elements that is going to be another array. That seems familiar with Java. A new for the array, and then another new for each of the rows in the array. But we're going to review that in the next lecture. Mallocs for bidimensional arrays. We play with that. Just think about it. We continue next lecture. Okay? Good. See you guys.